Alright, so in this session, we are going to we're stepping into one of the most powerful ideas in programming, which is loops. So far, you have written code that runs line by line. It starts, does something, and then stops. But what if you need to do something over and over again, like print a message 5 times, check multiple items in a list, or keep asking a user for input until they give a valid answer. So that's where loop comes in. A loop lets your program repeat a block of code automatically without you having it having to write it multiple times. So it's like telling your program, keep doing this as long as the condition is true. So now there are different few different kinds of loops in Java. We have while loops, do while loops, and for loops. So they all do the same thing, same basic thing, repetition, but in slightly different ways. So while loop runs as long as its condition is true. For example, imagine you want to print hello 5 times. Let me write an example. So yeah, if you're trying to print hello 5 times, you could write something like int count is equal to 1, uh, while uh, count less than or equal to 5, uh, and your statement dot hello. Now increment it. So yeah, this is a simple example for a while loop. So here's what's happening. The loop starts by checking the condition count less than or equal to 5. If that's true, it runs the code inside, which is prints hello, and then increases the counter by 1. So when count becomes 6, the condition is false, and the loop stops. So in short, a loop depends on a condition. It keeps going while the condition is true. So now there's an important warning here. If you forget to update your loop variable, like in this case, it's count plus plus, your program will get stuck forever running infinitely. So that's what we call a infinite loop, and you'll see you'll see one at some point. So it's a rite of passage in programming. So if that happens, don't panic, just hit stop, fix the update, and rerun. And the next two loops are do while and for. Follow the same pattern but with slightly different structure. The do while loop guarantees the code runs at least once before checking the condition, and the for loop is great when you already know how many times you want something to repeat, like counting from 1 to 10. So we'll explore those in the next topics, but for now just remember, a loop is your program way of saying I've got this, I'll keep repeating it until the job is done. So as you go through the books this week, don't just read the examples, run them, try small tweaks, change the condition, remove the increment, and see what happens. Watch the loop behavior. Uh, Watching the loop behavior is the fastest way to truly understand how it works. Uh, yeah, that's it for the intro for loops. We're gonna discuss the details in the next sections. So uh, yeah, let's see how to actually write and control them effectively. So while loop, first we have while loop. So we talked about loops in general. So that idea of making your program repeat something automatically until a condition changes. So now Let's focus on one of the most common and useful types of loops in Java, which is the while loop. So while loop is basically your program saying keep doing this while something is true. So you set a condition, and as long as the condition remains true, the loop keeps running. The moment it becomes false, the loop stops. So think of it uh, like a real world example. You keep walking while the light is green, and the second it turns red, you stop. So that's the same mental model for your while loop. So let's break down how it works in Java terms. So a while loop has three parts. I think I can take this example again. So we have a starting value, uh, usually a counter or a variable that keeps track of progress, and a condition. So a condition, what must be true to keep looping, and an update. An update is something that changes each time, so you eventually break out of that loop. So here's a small example, simple example you might picture in your IDE. You can start with a variable called count. uh, we want to print numbers from 1 to 5. So each time the loop runs, it checks is count less than or equal to 5. If yes, it prints the number and adds 1 to it. So when the count finally becomes 6, the condition is false and the loop ends. So this is the same example as this. Instead of hello, you print the count. uh, yeah, this should print 1 to 5. uh, so it's like saying keep printing numbers while count is 5 or less. So uh, yeah, now one of the most common beginners mistakes, and everyone does it at least once, is forgetting to update the loop variable. So if you never change count, the condition will always be true. Your program will never stop. That's called an infinite loop that I mentioned. It'll keep printing forever until you stop it manually. So if that happens to you, don't panic. Just look inside your loop and make sure your variable actually changes on each pass. So while loop are especially great when you don't know ahead of time how many times something will repeat. For example, maybe maybe you're reading input from a user and you don't know how many times they'll respond. So you could write something like this conceptually, like keep asking the user for input while they haven't typed exit. So each time you read what they typed, check for the condition, repeat until they're done. So that's where while really shines. It's flexible, reacts to the real uh, real time input instead of fixed count. So to summarize, while loop checks its condition before each run. If it's true, the body runs. If it's false, the loop ends. Always make sure something in the loop moves you closer to stopping. That's your exit strategy. So when you get into Zybugs this week, try playing with your loop conditions. See what happens if you change less than, or less than to less than to less than equals, or if you forget to increment the variable, what's the behavior. It'll help you feel how the loop flows. So that's it for while loops. uh, yeah. Now next we'll see the other loops and see how they fit into the same idea of controlled repetition. uh, Before that, we'll look into some examples. So we talked about what a while loop is. It repeats something as long as a condition is true. So now let's look at some different patterns you'll see at all the time with while loops. Things like countdowns, totals, validation. So these are the kind of loops that actually make your programs useful. So first one, we have countdown loops. So this is a simple one. So instead of counting up, sometimes you count down. Imagine you're building a timer. You want to start from 10 and go down to 1. So each loop run subtracts 1. So when you hit 0, it stops. So this kind of loop is great for uh, progress bars, uh, like even game countdowns. So the main thing to remember is the condition still controls when it stops. Whether you're counting up or down doesn't matter. So if you accidentally go the wrong direction, that's how you get infinite loop. So double check your update step. So next pattern, probably the most common one, is accumulating loops, accumulating totals. So this means you're adding things up as the loop goes. For example, say you're reading integers from the user. You want to keep adding them until they type 0 to stop. So you start with the total of 0. Each time through the loop you add their number to the total. So when they enter 0, the loop ends and you print the total. That 0 isn't just a number, it's what we call a stop signal. uh, it's a value that tells the program, okay, we are done looping now. So this idea shows up everywhere, not just with numbers. You might read 5 lines until you hit the end. So or get text inputs until the user types quit. So it's the same concept, a loop that runs until it sees a signal to stop. Another really common pattern is validation loops. So checking that input is valid. So for example, if you need a positive number, you can loop and keep asking until the user gives you one. While the input is invalid, the loop repeats. Once they type something acceptable, the loop ends and program moves on. So this makes your program more reliable and user friendly because they don't crash when someone types the wrong thing. Next we have debugging. So let's talk about debugging. So while loops are awesome, but they can also be sneaky. If you ever feel like your loop isn't doing anything, try printing a message inside it, like the current value of your counter or input. So that tiny debug print can save you hours of guessing. It lets you see how the loop is behaving as it runs. You'll often find you made a small logic mistake, like not updating a variable the right way. So yeah, while loops are flexible, you can count up, count down, add things up, or wait for stop signal. But every loop needs three things: condition, update, and a way to end safely. So play with these patterns. Try writing a countdown. Then try a total accumulator, and try a validation loop. And each one teaches you a different side of how looping really works. So yeah, that's it for this one. Uh, Next, we'll look at how for loops gives us a cleaner way to handle repetitions when we already know how many times we want to run. Uh, so for loops. So far, we talked about a lot about while loops, loops that keep running while something is true. Now we are moving into another super common type of loop, which is the for loop. You'll see this everywhere in Zybergs, in your IDE, honestly, in almost every real Java program. So now let's talk about what makes the for loop special and why programmers love it. So think of for loop as a compact way to write a while loop. So It's perfect for situations where you already know how many times you want something to repeat, like counting from 1 to 10, printing 10 rows, or checking 5 items in a list. So the structure is basically initialization, where you start, and you'll have a condition where you when you stop, that's your condition, and update is when how you move forward. So it's like saying start here, keep going while this is true, and after each loop update this variable. So let's walk through an example. So imagine you want to print from 0 to 9. You start with 0, that's your initialization, like something like int I is equal to 0, and then you say keep looping while the number is less than 10, that's your condition, and finally you add one yeah, you add one each time, so that's your update. So it's like it repeats 10 times total, printing 0 through 9. Let me actually write that. Actually, I'm gonna for let's say count is equal to 0, uh, then your condition count less than 10, and your incremented count plus plus. Yeah, this is an example. So here's a cool part about for loop. So for loop and the while loop actually do the same thing. They just recognize the pieces differently. So in while loop, you usually have uh, so in while loop you usually have start before the loop. So the condition in the while, parenthesis, and the update inside the loop body. So in for loop, the first three pieces, start, check, and update, live right at the top, as you can see here. Uh, so that makes it cleaner and easier to read when you know exactly how long the loop should run. So whenever you count or predict the number of iterations, a for loop is usually the best choice. So here's one classic problem to watch out for, uh, which is off by one errors. So this happens when your loop runs one time too many, or one time uh, too few. So it's usually comes down to how you write your condition, like using less than instead of less than or equal to. For example, if you want to run something 10 times but accidentally stops at 9, that's an off by 1. It's tiny, but in real programs you can completely break logic or miss data. So a good habit is to double check your start and end points when testing loops. So sometimes even printing the counter value can help you confirm you're getting the right number of runs. So yeah, for loops are great when you know how many times to repeat. They are made for they're made of three parts: start, condition, and update. So they are just a cleaner version of while loop. Watch for off by one errors. They're small but sneaky. Uh, so when you're practicing in Zybooks or your IDE, try converting a while loop into a for loop. From what we have done, similar to what we did here. Uh, and you'll see how similar the logic really is. It's just written in a tighter, neater package. So yeah, that's it for loops. It's one of the best tools in your programming. uh, so next we'll see a few more patterns that will help you get more out of looping. uh, so now that you understood the structure of for loop, let's look how it actually used in real programs, not just count numbers, but to do useful work. So the for loop is one of those tools that pop up in almost every program you'll ever write. It's simple but incredibly powerful once you start recognizing patterns. You can use it to calculate totals, analyze data, or repeat tasks across arrays or lists. Basically, anything that needs to run a set number of times. So let's start with one of the most common patterns, which is summing a range of numbers. So imagine you want to find a total of the numbers from 1 to 10. So instead of adding them manually, you let the loop handle it. So you start with a variable, say sum is equal to 0. Then your for loop runs from 1 to 10, adding each number into that sum. So by the end, you've got the total, and all in just few lines. So that's the power of loop. It replaces uh, it replaces repetition with structure. So you could even extend that idea, like maybe sum of first n numbers, where n comes from user input. It's the same loop, just flexible enough to handle any range. Another common pattern is selective looping. So where you only process some of the values. For example, maybe you want to print only even numbers between 1 and 20. So you can easily check each number inside the loop and only print if it meets your condition. You know how to check an even number. So that's the you'll integrate that logic into your for loop. So this kind of filtering shows up all the time in real programs. Think only active users, only scores above 80. So similar kind of examples. And you'll also see for loops used heavily in arrays, with arrays or lists. So imagine you have a list of test scores or names or items in a shopping cart. So you can loop through the list one element at a time, process each, and maybe calculate an average or find the highest value. So the pattern is always the same. Start with an with a start at the first item, move through one by one, do something with each, stop when you've reached the end. So once you start recognizing the rhythm, start, condition, update, it becomes second nature. So the one thing I really want I really want you to remember is the loops are about patterns. So you'll see the same few ideas over and over, just dressed up for different situations. So counting up or down, adding things up, checking conditions, processing data, they're all variations on the same loop shape. So when you're writing your own, take a second to think, what am I looping through? What should happen each time? So that's kind of mindset makes looping much less scary and way more logical. So yeah, use for loops when you know how many times to repeat. You can use them to sum numbers, print patterns, walk through arrays, focus on recognizing loop patterns. That's what helps you reuse uh, logic instead of rewriting it every time. And remember, run your examples in your zybooks or your IDE and actually see the loop in action. So print the values as it runs, watch how it changes each time. So once you predict the pattern, you will really understand how loops work. So that's it for this section. We'll in the next session we'll start mixing loops with other data types to make more dynamic programs. Yeah.